Welcome at the webinar of the project Circular Wood for the Neighborhood. My name is Tony Schoen. I'm the manager of the project, and today we will dive into this project with a number of presentations. Unfortunately, two of our presenters have become ill with corona, so we will only have 3 presentations this morning, which gives us a lot of time also to answer questions from you. So the presentations from Rochdale and the Municipality of Amsterdam have to be cancelled, unfortunately. So we will have 3 presentations in this session. First, we will have an introduction of the Robot Lab by Marta Malé-Alemany. Then we will have an introduction of circularity in the buildings with a focus on wood, of course, by Nico Schouten from Metabolic. And then finally, we will have a presentation by Marco Galli, designer and researcher of the project, who will share with us the results so far. At the end of each presentation, there is time for questions and answers, so please post your questions in the chat, and then we will discuss them with you after each individual presentation, and maybe some general questions at the end of the webinar. So far, so good. Let's go to the first presentation. Marta Malé-Alemany.
Thank you, Tony. Welcome, everybody. So I'm going to be introducing the Robot Lab and the Digital Production Research Group from the Hogeschool van Amsterdam, the Amsterdam University of Applied Sciences, where this project is actually, that is initiating this project, Circular Wood for the Neighborhood. So I'm going to introduce you a little bit about the Robot Lab. I'm going to tell you what we are doing in terms of digital production in the circular transition, and in particular the wood projects that we are engaging in. I'm going to explain you generally what the Circular Wood for the Neighborhood project is, and we're going to look a little bit ahead of the upcoming projects that we have in the research group, so that you see a little bit where we're going with this. And of course, we will have a Q&A at the end of my presentation. So what's the Robot Lab? What's the Digital Production Research Group? Most of it, the Robot Lab is our home, is where we do the integration of research, education, and practice. And at the Digital Production Research Group, we explore the added value of digital production to address urgent societal challenges. We do this with key technologies like computational design, robotic production, computer vision, AI, mixed media, etc. We do this very much aligned with our university strategic plan, sustainability, digitalization, and inclusion. And in our Faculty of Technology, we are aligned with 3 profiling themes, that is smart industry, circular transition, and designing future cities. In a nutshell, what we do is we look at the smart industry, we tackle the problem, or we want to contribute to the circular transition, and what we do, circular applications. So we want to participate, therefore, to the main goals of this city that it has intention to become fully circular by 2050, with the goal of reducing 50% of the use of raw materials. We are using robots in our exploration. Many times we are asked why robots, and the answer for us is twofold. One is because these tools are very versatile. They can do many different things depending on the tool that they are carrying, depending on the process that they are designed for and programmed for, etc. And for us, very important, it's our means of upscaling into the industry and into the market the solutions that we develop at the lab. Who we are a very multidisciplinary community. Within the team, we have architects, engineers, industrial design engineers, mechatronica and robotica experts, programmers, and more. And we have a large group of students in different courses within the Faculty of Technology and the Faculty of Digital Media and Creative Industries, but also we are joined by interns and graduates every semester that work with us in the team for 6 months. How we work, we empower our students. That means that we let them directly have contact with these technologies so that they learn through experience. We have with them a very active collaboration, very horizontal, between our group of researchers and the students. And most importantly, we learn by doing. So that means that, and what we do is, of course, we make things. So we are using those industrial robots for robotic production, and we are using computational design to design specific objects that are almost perfectly suited to be produced with such technologies. Here you have a little bit of impression of what the Robot Lab is at the moment. We are moving into a new location in the summer, so this is a little bit the current circumstances, but you see here our robots using 3D scanning, our students being involved in these projects concerning circular or residual wood, how we work with computational design, and how we are basically experimenting with different processes of manufacturing for wood, like engraving, milling, and so on. And then you see also that we work as a team. You see that there is a lot of collaboration between the students, peer-to-peer learning. And of course, there is still quite some manual work that we will try to automate more and more through the use of robots. And well, that's where we prototype things at the lab. We actually put them together, and at the end we make circular applications that can be installed on location, like this reception desk that we did for the Johan Cruyff Arena here in Amsterdam, that I'm going to be speaking about a little bit later. So, introduction, what do we do in digital production for the circular transition, and in particular our wood projects? This started already a long time ago in 2017 when we started the Robot Lab. We were already wondering, wow, what do we do with all these materials that are collected as waste in this city? Wood being one of the biggest, I think it represents 42% of the domestic waste of the city. And the knowledge that through digital production, maybe we could remanufacture this wood and give it a new life, new applications that therefore we could add value to a material that otherwise would be considered waste. Since then, we have done many projects with that in mind. For instance, this project RoboWood, in which we began to develop tools for our robots that were able to pick up variable pieces of wood. We have done also several conversation pieces, like this circular lounge chair from using wood from one of the waste collection points in the city, and reassembling the wood and remanufacturing so that it would have a different shape, a different kind of value. And we have done also projects like DataWood, in which we are now busy also in relation to the wood intake, thinking that if you were to work with circular materials, and in particular wood streams that come in different sizes and different shapes, then if you wanted to know what do you have, you would need to first 3D scan it, take all the dimensions of the pieces of wood, generate a material database that you can connect with your 3D modeling software, and only then you would be able to design knowing exactly the material that you have available. So we have been working for a while in our research group with this vision of automating wood upcycling in some way, where we would have a sort of factory setup where we start with residual wood and we end with custom-made products in the other end. And in the process, we have explored different robotic production processes that made that a possibility. So I'm going to show you a very quick project that we recently finished last year. It's a reception desk, as I said, for the Johan Cruyff Arena, the stadium of Ajax here in the city, where we worked exactly this with parametric design tools, but also pairing the parametric design tools with the material databases that we had previously scanned, and previously photographed, so we knew the color of the wood, the sizes of the wood, and so on, and where we did a process of optimizing what should be the most ideal position of every piece of wood in the design structure, such that at the end we worked with algorithms to organize and, if you want, orchestrate the relationship and the position of these pieces of wood to develop this desk. Here you see several algorithms at play in the final design, where lighter wood is at the bottom, darker wood is at the top, shorter pieces are at the ends, longer pieces in the middle, thicker pieces at the bottom to receive more weight, thinner pieces at the top. So to optimize several aspects of this desk. Every single piece of this desk is actually manufactured with unique joints to connect to the other pieces, but in a way all numbered for assembly on site, and in a way to be assembled without glue and without screws, so that is easy, is a kind of idea of design for this assembly. We at the lab we tested all the robotic production of these joints. We tested what would be the assembly on site, with the idea that you would transport all the pieces with a minimal amount of volume. There again, another contribution to diminish the carbon footprint of this project, and be assembled on site by people that not necessarily were part of the production process. That's the completion of the project at the Johan Cruyff Arena. We're very happy about the result, mainly because what you see here are 300 pieces of leftover industrial hardwood that, if they did not become this desk, would have been burned. And therefore, we have been able, through computational design and robotic production, to bring it back to existence, if you want, create a valuable object, and therefore prove the added value of these technologies. That brings me to circular wood for the neighborhood. That is the project that we are presenting here today. It's a project that is financed by SIA. It's a RAC Public project where we work with, therefore, public institutions. That includes large housing corporations, IJmere, Rochdale, their co-makers, Lemferink, Rutgers, but also collaboration with knowledge institutes like TU Delft, Metabolic, demolition companies, GP Groot, and waste collection companies, but also TNO, the Gemeente Amsterdam, Platform 31, and of course our technical partners at the Robot Lab. And here the challenge is, in a nutshell, is to look at what is the waste wood that is generated when maintaining or renovating the buildings that they have currently in their portfolio, and even demolishing some of these buildings as well. And can we harvest part of this wood that is still in good condition and make applications for those housing corporations so that we can close the circle of wood and eventually give added value to the housing corporations by not burning this wood? We have worked in this project in doing material flow analysis. That's the collaboration with Metabolic that Nico will be speaking about in a little while, but really understanding how much wood is there in those buildings, and what kind of percentage of that wood would be able to use. In the Robot Lab, we have also been busy with exploring robotic wood waste processing. What would we need to do if, for instance, we recovered old doors from these buildings and we wanted to reuse the wood that comes available from those doors? We, of course, worked with this idea of the digital intake, how to know exactly what kind of materials do we have available. And that is, in fact, the principle of having a material database that you are able to design with. We have done exploration on the creation of circular products, so where we have taken pieces of old window frames, old door frames, and remanufactured them with the robot, and then reassembled them in maybe differentiated kind of building elements like a window frame. And we are now, and here I'm using a picture of the ETH as a reference. The last structure is not by us, but we are at the moment developing more advanced computational design processes to assemble pieces of window frames that are hardwood, good quality wood, for the creation of more complex kind of structures. And we are seeing this, that at the end, we are also thinking about the idea of maybe shared material banks between different housing corporations that could be at the creation of structures that could add added value to, for example, the revamping of the neighborhoods where their buildings are located. So in a kind of shared value between housing corporations that do normally not collaborate on that level of sharing circular materials. The kind of work that we are currently doing for developing these structures, we are really, again, developing databases, working with an idea of so-called target structures, and what we are doing is fitting the wood that we have available to a kind of desired, if you want, target structure. And with that, what we are beginning to see is that we are able to create unique circular structures from a certain wood stock that comes available, that we can, of course, sort and through various algorithms decide in which pieces of the structure should each piece of the stock be located, and what would we basically have as a result. We are also pairing that with the structural analysis of those structures, and with the idea that we could maybe create playgrounds outside of the buildings, and therefore bring added value for the community that lives on those buildings. That brings me to tenant engagement. We are now discussing with the housing corporations how could the tenants be engaged in this process, because we think that the computational tools that we are implementing could very well facilitate a process of co-design with those tenants if they were given the chance to tell us what would be their desired outcome of all of these, and why not also think about the tenants participating in the construction of those structures as a means to also create more community and a closer community, more that feels ownership in relation to the development of their own neighborhood. And last but not least, we are wrapping up the project as we speak. We are looking at all the learnings that we have had by working with this amazing group of partners, and we are developing some recommendation or implementation strategies for housing corporations about what we see could be a potential viable future for thinking in a more shared value, more collective way, and to really be able to facilitate renovation projects that use the circular wood that comes available and can be harvested from their own buildings. Having said that, I just give you a little bit of an insight about our upcoming projects, because that, of course, what I spoke about is not possible without production facilities that go along. We are now going to engage in a project called Circular Wood 4.0, where we are going to work with yet another great set of partners, looking really at bringing smart industry and automation to the possibility of wood upcycling, and therefore having the means to increase the volumes of production. again, back to this vision of the automation for wood upcycling, we're going to be doing a kind of digital twin of this factory that will allow us to simulate production, evaluate the KPI framework, the key performance indicator framework that we have developed for circular wood. And eventually, most importantly, can we meet the business case that is necessary to turn residual wood that is considered waste into valuable products, and can we support the production process that is between the two? And then far in the horizon, we would like from the research team to contribute with creating generative design tools that make all of these let's say, process of designing structures with non-linear material streams available to designers and available to corporations that could eventually make use of it. We think that sooner or later this might require some wood upcycling on location, either to pre-process the harvested wood or else to produce some of the structures with the tenants. And we see that the city, and we are having several conversations with several parties on how to bring circular production in the city as this idea of the living labs. And at the end of the day, what we would like to leave behind as a research group is that we have contributed to bring in the Industry 4.0 that is now not busy with circularity whatsoever, but to really bring that field into a new domain. And if so, and we keep on the goal for Amsterdam Circular 2050, will the Industry 4.0 be a key enabling technology of that? We think yes. That's what we're going to work on. And well, last but not least, we are at the lab doing circular applications, and hopefully we can work in full-scale demonstrators where we, in relation to that city goal, we can show and somehow showcase what we can do with harvested wood from the city. Thank you very much. That was it for me.
Thank you, Marta, for this very extensive introduction of the Robot Lab and the projects that we're doing with wood. I must say, you mentioned very briefly the implementation strategies, recommendations, and I was wondering if you already have a very one recommendation which you have learned so far from the project, or is that too soon now?
Well, it's a little bit soon, but I think that maybe what we can do is that we can leave a little bit the part of implementation for the very end,
okay,
because I think it has very much to do with what Nico will be presenting about the some of the difficulties that we find in harvesting such wood, but also the potential that we see from the harvesting and from the collection of projects that we have looked at. And I think also after seeing the work that Marco will be presenting, I think it's easier to...
Okay, let's leave this for the end then.
To speak about that.
We have a few questions from our participants. The first question is, what kind of design do you use when you work with waste wood? How do you approach it?
Well, I think maybe I was too quick, but I'm going to go back to this question. First, everybody needs to understand that when we speak about circular wood, it is basically wood that comes in different dimensions and different sizes, different types, different qualities. Because whenever you harvest wood from an existing building, from a waste collection point, or even from a wood processing industry, it doesn't come in standard sizes, because maybe some of the elements are rotten in some places, so you need to cut out a piece of the wood. When the wood processing industry have leftover pieces, they have leftover pieces from cutting the size of the piece that they need and leaving pieces of variable dimensions behind. So by definition, circular wood is a non-linear waste stream. So with that in mind, we need to know, when you receive a bunch of circular wood, you need to know what you have, because you cannot say, I have 30 pieces of the same dimension. That's not true. In fact, you don't know. So the first thing that you need is a proper digital intake, which basically will mean 3D scanning the pieces to know their specific dimension, but that also can involve weighing the pieces in order to know their density and eventually come closer to determine what kind of wood it is, what type, because if you know the dimensions and you know the density, you'll come a little bit closer to know what type of wood you have. But also you need to see if there is metal inside, because if the wood comes from a wood processing industry, it's origin wood that comes in variable dimensions. But if it comes from a harvested building, the likelihood that there are nails inside is very high. And you need to know if there are nails, because otherwise you could hurt your wood processing tools. So with that digital intake, you can have a much clearer idea of the wood that you can actually use for your project. So that's the first step. And then what kind of design approach you take is, of course, it has to be a kind of computational design approach that is able, one, to generate forms that are non-standard, because you depart from a material database that is non-standard, and in the best of conditions, that is able to generatively match the pieces that you have available to the design target that you have in mind, and then propose several versions of that you can then optimize, that you can then analyze, that you can simulate the structural behavior for it, etc. That's one way. And the other way is to say, okay, I want to design more or less, not that every element is different, but I want to design always the same element or something similar, but you might then be able to combine different pieces of wood to generate the same element. And there again, you need algorithms to determine what's the best position of the pieces of wood to make that standard element. So either you have a standard outcome or non-standard outcome, but either way you need to know what is the material database that you depart with, and you need computational design to algorithmically make the match between the design goal and the wood that you have available.
Yes. Yeah, for me the biggest challenge always is to understand that you are designing with a limited resource of materials and not with unlimited resources where designs mostly are based on. So another question is that you scan the material and you put them in a database. So can this also help to bring the inner material qualities visible in the design?
And by inner, what do you understand by inner in this case?
Well, let's
intrinsic.
Yeah, the intrinsic in itself.
Well, the thing is exactly this. What we have seen in the Bali, in the reception desk for the Johan Cruyff Arena, is that because we departed with pieces of wood that were of a different type and had different colors, then we could use the algorithms to create a gradient from lighter wood at the bottom to darker wood at the top. And there is an example of using the materials that you have available and bring them as added value to your final design. So I think that the best outcome of all of these would be, one, that we find methodologies to reuse the harvested wood that we have available. And two, is that those design methodologies allow us to explore the uniqueness, the aesthetic and structural uniqueness that we can create with those materials that are not of the same kind. So the reception desk, I think we made an attempt of exploring that by not only with the color, but also with the thickness, for example, by placing the thicker pieces at the bottom and the lighter pieces at the top. We could also, the wood distribution also was helping in stabilizing the structure on location. So these are examples.
Yes. Well, I think you could go on much longer if you had more time, but it's time to move on to the second presentation. But before, I would like to ask you, to already think about these implementation strategies and which one is your favorite recommendation, which you now already have found, so that we can have a quick discussion about this at the end of the webinar.
Very
Let's
good.
move on to the second presentation, which will be done by Nico Schouten from Metabolic. He is a project participant in the Circular Wood for the Neighborhood project, and he has really helped us in sharpening the concept of circularity and the, let's say, the relevance of the project for the circular economy. So, Nico, the floor is yours.
Thank you. So today I'm going to talk about two things. First, of course, is the impact of circular, of the concept of the circular economy, and that's some of the research that we did for Circular Wood of the Neighborhood project together with me and them. So first, a bit about the role of wood in the circular economy. When we look at the world that we're living in, we can see that we live in quite an extractive world. We are consuming a lot of materials on a basis, 90 billion tons per year, of which only 20 million tons is bio-based material, so like trees, also food and fish. And of all these materials, only 8% is currently being reused or recycled at the relevant rate. So all the other materials are currently being downcycled, which means that we're extracting materials at the Earth very alarming rate. Of course, 19 billion tons of material is quite a lot, and it's a bit daunting to think of such a large number. To make it a bit more concrete, it roughly translates to 11 tons of material per person on this planet per year. So it's really a lot of material that we're consuming on a yearly basis. And with consuming all this material, we're also generating a lot of impact. It's very much because of the linear economy. So we have an unsustainable model where we take material, process it, and then we dispose of it. Throughout this entire process, we generate a lot of environmental impact. This environmental impact can be known both CO2 emissions, but also in land. And because of all this consumption, we are actually crossing a lot of planetary boundaries. When we think of planet Earth as a spaceship, and in a spaceship you have certain parameters to make sure that we can live there okay. Because we consume so much material, we're actually making sure that these parameters or boundaries are crossed. So a very famous one is climate change. That's the one we talk about. It's the 1.5 degrees that we've agreed on in Paris. And how this works is that you have the green zone, which means that you're okay within the system of planet Earth. Then we have the orange zone, which is we are coming to a certain extent of danger. And then we have the red zone, which means that we've crossed the planetary boundaries, which means the system of planet Earth can no longer function in the way it was supposed to. It will change because we don't know what way it will change, but we almost know for certain that it will not be kept. And when we think of climate change, you know, it's a very pressing issue. We hear a lot about it in the press, but when you look at this whole schematic, we can see that there's actually a lot more boundaries that we have to think about. So we have biospheric integrity, we have land use change, we have freshwater consumption and biochemical flows, and some more. And as you can see, some of these boundaries in our system have already. We have a huge loss of biogenetic diversity. We have very much disposition of nitrogen phosphorus here in the West and a huge shortage of it in other parts of the world. And this makes it much harder for the ecosystem of Earth to facilitate us in the way we live. So make sure that we can actually live on this planet pleasantly. And why I show this image is because I think that sustainability is very much about the systems approach. You can't look at just one part of a problem and say, okay, I'm going to solve this one without looking at the other parts, a bit like a Rubik's Cube. If you focus on the red squares, you can get all the red squares to one side of the Rubik's Cube, but you will not have solved the entire issue. And to have this more holistic approach, we usually work with the 7 pillars of the circular economy, which was generated by Metabolic, where we not only look at materials, but also at energy consumption, water consumption, the impact of biodiversity, human culture, health and well-being, and value. Because if you don't take all these 7 into account, then you're really shifting the problem from one side of the spectrum to the other without really solving the problem. We can see from the crossing of its planetary boundaries and this really single-minded approach towards sustainability, we can see the first effects having its toll on our planet. So we have light pollution, we have drought, we have deforestation, we have air pollution, and one of the most famous one maybe is, of course, the global temperature change that we've been seeing over the past 1.5 centuries. So we know that since the beginning, since the last 100 years, our planet has risen in temperature approximately 0.8 degrees Celsius, and we are on a trajectory to really cross the 1.5 degrees Celsius global temperature rise that we saw in the parameters for the planetary boundaries. And why I'm specifically talking about this carbon budget right now and this global temperature rise is because since very recently we've started to work with carbon budgets. So we actually know how much carbon there's left in the world before we will cross this 1.5 degree. We can see that of all the carbon that we've been emitting, we have left 7% in our budget before we cross this 1.5 degrees, which would roughly translate to 7.5 years to go emissions that we've been having so far. And we can see that when we divide the share over the participants of the world, we can see that actually the European Union has a very low percentage that we can still use of this whole carbon budget. And when we translate this towards the Netherlands, we can see that for the Netherlands to stay within our fair share of the carbon budget, we only have 1.5 to stay within 1.5 degrees. We have actually less time, so within 4 or 5 years, in the year 2026, our carbon budget will be gone. So we need to change the way we consume materials, and we do that. And how can we best do that is to take factors that are really affecting us the most. So when we look at cities, we can see that they're a very small share of the land surface. They occupy 3% of land, but they consume 75% of global resources and produce 60 to 80% of global greenhouse gases, which is, of course, very much, but means that if we tackle cities, then we can really make sure that we push the deadline for the carbon budget back. At the same time, we can also see that the built environment, especially in the Netherlands, is very. The Netherlands consumes the built environment in the Netherlands consumes 40% of all our energy, for which the majority is used in the use phase. 50 to 60% of all our material consumption is used in the built environment, which the majority is used for construction, and then 40% of our greenhouse gas emissions are tied to the built environment, of which 75% again is tied to the use phase, and 24% is related to material consumption. So by looking more sustainably and circular at materials, we can really reduce this. That's why looking at circularity from a more holistic perspective, the goal is not just to stay to reuse or recycle materials. It's really to find high-value reuse purposes for materials that we're currently consuming to ensure that we reduce the environmental impact that we cause our system. With the planetary, with this whole recycling of materials or high-value reuse within the circular economy, it can reduce consumption of virgin materials significantly, and also reduce the environmental impact or the emissions, CO2 emissions by 39%. So that's really a lot when we look at all the impact that we're generating as a country, also as a species. Then when we look specifically at the built environment or the built sector, we also, well, as I previously mentioned, we consume a lot of materials. So this image you see here before is a material flow analysis that we did together with the Economic Institute of the Built Environment in the Netherlands, where we mapped all the material consumption for buildings and construction in the Netherlands up until 2030. What you can see on the left is all the materials going into the environment. So we have a lot of concrete, and steel, and brick, and actually divided over different typologies. They're like offices, shops, but also family homes, houses, and then also all the material that will become free from now to 2030 because of demolition. What you can see there again is a lot of concrete, a lot of rocks, bricks. But what also really is noticeable is that the inflow of 17,000 kilotons and the outflow of 7,000 kilotons don't match. So even if we reuse 30 to 40% of all materials, we still only have enough to facilitate the growth of our buildings by 30 to 40%. So that leaves us with two things to do. One is to reduce the need for unsustainable virgin building materials to ensure that we don't consume as much or emit as much CO2. And one is to reuse all the outgoing building materials that we have the highest potential value. What do we mean with high value or retaining value? The best example is to show you this image, which is called the value hill. So in the current system, we take materials, we make products out of it, we sell it, and we use it. And then at the end, when we don't longer have a function for it, we basically throw it away. It's either burned or landfilled, which means that we destroy all the value that was put in the product. But we can do the same with materials from a circular perspective. So we make products, then we use it. And the first, of course, is to really maintain or extend the use period as much as possible, because then you don't need to buy new products. And then we really apply the air ladder, talk about reuse or distribution, refurbishment, packaging, which actually keeps the value of this product much higher, much still, and making sure you don't need new products. Also, these processes of reuse and redistribution, refurbishment, has a lot less impact on the environment, so also being much more sustainable. So when we look specifically at wood in the building sector and high-value reuse applications of wood, we can see that 5% of all the materials that are going out of the built environment are wood, bio-based material. And in the current system, this wood is either being downcycled, so turned into particle board, or more likely being burned. But if we were to reuse this wood in this high-value application that I just talked about, we could actually facilitate almost 60% of the wood that we need for construction in the current building practice from now until 2030. Actually, quite significant amount of material that we could save and prevent deforestation from happening. And this is basically the point apart that we took for the Circular Wood for the Neighborhood project. We analyzed the material flows for these different housing corporations and also assess the environmental impact and potential saving we could have if we reuse these materials in a high value fashion. We analyzed 5 building projects from IJmere, 7 building projects from Rochdale, where we made a nice spread over different types of typologies from and use cases from both corporations. And what was really important for us, and also analysis of this project, is that we took projects which really reused a lot of wood to make sure that the business case or the impact that we assessed makes sense for the case that we were doing at the Haven. What it looked like for IJmere to start with. You can see here a material flow analysis again of these different projects on the left. And these are specifically specified on dates. So there's the first one will be in November, then we have May, June, and August of 2022. Here in the second column, you can see the elements that are being reused. But there's either rotating windows, there's doors, there's profiles. You can see that by far rotating windows are the largest. And then you can see the amount of wood that is either divided on class, and it's currently this material. So when we dive a bit deeper, we can see that 40% of all wood is rotating windows. If buildings, 28% of all wood door, which make a very nice hotspot to focus on. That if you can do something with either these rotating windows or doors, actually have captured a very big part of all the material that is coming out of the project. At the same time, we also looked at the quality of the wood. Important when you want to reuse it. And then what we did is that we looked at the NEN norms for renovation, which were applied by IJmere. It's divided wood over types of classes, where class 5 is actually very poor quality and class 0 is actually quite well. And based on the current building system, we said all of class 5 wood would be burned for energy recovery. Class 0 would be downcycled into particle board. That's what's currently happening with the majority of these types of. Also assess what type of material was being used for these specific components. You can see that we divided it over 3 different types of wood. So softwood, hardwood, and plywood. So the majority of all rotating doors is actually softwood, but which is then also majority of all the material being from the IJmeren Kappa projects. But hardwood is almost 11 cubic meters of material, which will roughly translate to 44% of material. So softwood is 12.8 meters of material, which is roughly 52% of material. And again, this is very useful information if you want to reprocess, as Martin told before, because softwood processing is very different. So, of course, the quality of hardwood and also the potential value of hardwood is a lot higher. It's usually durable material, which means that the state likely a lot. And we focused on rust. We also made a material flow analysis. And what we see here is then instead of the date focused really on specific building projects, we can see that this first project, Havestein project, is very big. It's 131 cubic meters of material would come available. That again, the elements, so different window frames, doors, and windows, the majority of streams, and waste stream. And what is very interesting to see is that in regards to data collection, we have a very different approach, which is a lot harder for us to assess the quality. So there, we actually mapped this impact stream, used just what would at the end of life, where a big part again is incinerated for energy recovery and a very time. On the hotspots, we can see that almost 51% of all the wood is from one project. So from a spatial perspective, it's also interesting. And it's good to double down on really tackling this project, also prevent additional transport to make sure that you can actually really impact the one go. And the second one really focuses on apologies. 30% of it's coming from wind
Nico,
frame.
may I interrupt you briefly, Nico?
Just as in the IJmeren project, we can see trend.
I don't have sound here.
Doors are wooden products which are being removed quite a lot, and which also have a very high, which give them a very high likelihood in recovery. Then again, looking at the incineration, we can see 60% rated for energy recovery, and that's really based. What was a bit difficult about this part of the analysis, that 75% of all material that we assessed, we knew it was wood, but we didn't really know specifically what type of wood, which makes it, of course, a lot harder to assess environmental impact using it. It makes it hard to say what the potential use case is, the types of the residual wood. We did see that 12 is hard, 1% softwood, so that's again quite a big chunk of hardwood that could potentially have a high value reuse project. So then, if we've done this as an analysis, there's a lot of building projects, we know that for sure. Next step that we really assessed is to understand what the impact was if we reuse this wood in a much more sustainable.
Nico?
That we assessed is that in total, cubic would be taken out of the properties of IJmeren.
Yes.
And of
Nico,
the 83 cubic meters,
your audio is
would actually come from commercial projects, because the majority of these projects were quite bigger. And if we were to grow this wood, so these 200 cubic meters of wood, it would take a forest of 120 square meters, around 30 years to grow this amount of wood, which is equals to the Oudster Park in Amsterdam. So we need a forest size of the Oudster Park to grow wood for 30 years to actually regrow the wood that we are now burning or downcycling. And then, of course, saying, well, that's not that much, but when you think about the fact that we've analyzed over 12 projects in corporations in one city, I do think it's quite an impactful metric to understand that if we reuse this material in a higher value, we're actually saving a lot environmentally. At the same time, we can see that if this wood is burnt, release of kilograms of CO2 into the atmosphere, that's the 125 cubic meters of poor quality wood that we're burning now, which would be the same as 29 households. Their energy consumption of 29 households on a basis. Again, just looking at these 12 projects and saying we can save of 29 households is again quite significant. Yeah, so that's the end of my presentation. I think overall, what we assessed in this project was quite interesting to see sheer volume of this material coming out of the project. Of course, there's been a lot of challenges with data collection, validating assumptions, and making sure the as close to the reality as possible. But I do think we can say for sure that there's a lot of potential and environmental value to be gained by reusing in a more sustainable and circular fashion. With that, I would like to give the word back to Tony.
Thank you, Nico, for this extensive presentation of circularity and buildings and how much wood comes available from renovations. When we are designing and making applications from this waste wood, I think it's a very complex system, and it's not so easy to tell which design is now the best, has the biggest impact on let's say on sustainability, on circularity, or maybe also on social aspects. Do you think it would be possible to have a system of impact factors which you could use to evaluate the sustainability or circularity of a specific application?
Yeah, I do think that. Of course, during the process, we also worked on a KPI framework where we specifically looked at factors like this. And I think one of the things to really understand is, of course, when we reuse the wood, we are preventing this wood to be burned. But at the same time, we're also preventing virgin material consumption. So if you really want to assess the impact of that you're making, you not only have to say, okay, I'm reusing this wood and preventing incineration, I also am maybe preventing the production of a steel info desk if we take the Bali, which is made by Johan Cruijff now. At the same time, you can also, of course, compare the financial aspect of saying, okay, if I buy a new desk, how much, or a new Bali, how much would that cost me compared to maybe the secondary desk, which would make a nice comparison. But at the same time, I think from a circularity perspective, it's also really important to understand values such as job creation, maybe softer values such as emotional value, which are added to the process. If you create a very meaningful job for someone by recycling this wood, then I also think that should be a very valid point that is taken into account when measuring the environmental impact of a sustainability intervention such as that. And I think that really ties back to the 7 pillars that I'm talking about at the beginning. Of course, on one hand, it's really about material reuse, but if you don't understand how this impacts job creation, how this impacts people's livelihood, how it impacts their health, or also other metrics such as energy consumption, then sustainability is you have the potential of shifting sustainability, but shifting the impact from one side of the spectrum to the other.
Okay, thank you. Another question is, there's only a small percentage of building materials which are being recycled now. Do you see what would be very logic means to increase this level? How could we encourage this to increase it from 8% to maybe 20 or maybe 100% in the end? What do we need for that?
Yeah, I think that's really a shared effort. So I think from a governmental level, it's important to make sure that the incentive structures are in the right place. So right now it's not as expensive, or it's very cheap to pollute actually. And I think if we put more stress on our financial burden on pollution, I think we will have an immediate shift towards the right benefit already. At the same time, it's very much about the way we're producing things right now. So a lot of the things that we are producing are very hard to reuse, or they're not made to reuse. And again, it's very much from a capitalist point of view that selling more product is always better. And so I think that's also something that we really need to consider. The products that we buy should last us longer than they do now, to make sure that we don't buy as much. And then the third part, I think, is really also about mindset. So we should all be aware of the impact of the things that we buy and the products that we have and the processes that we go through to make sure that we can shift them towards a different gear. I think what's really nice from an architecture point of view is that as an architect or a designer, you have can have influence on, well, the second and the third topic, but to really shift as a society towards a more holistic way of living or sustainable way of living, we need something from everyone. Yeah.
So we need a holistic approach, as you mentioned it in your presentation as well. Okay, with this we move on to the third presentation of this webinar. And I was wondering if Marco is around. Yes, he is. Ready to join me here.
Good morning, Tony.
Good morning, Marco. We have had two presentations now. We have heard a lot about the Robot Lab. We have heard about circularity. And now we're interested to learn some real results and ideas for the Circular Wood for the Neighborhood project itself.
Yes.
And I think you're the best to give us this information. The floor is
The
yours.
overview. Thank you very much, Tony. Well, good morning, everyone. My name is Marco Galli. I am, just as Tony mentioned earlier, a researcher and teacher at the Digital Production Research Group in the Faculty of Technology. My research has been focused specifically on the wood project, so there's our, let's say, field of expertise. And I will follow up a bit with what Marta started and connect also with the data that Nico has been sharing with us, and give you an overview of the work that we have done the past 2 years when it comes to exploring the digital production. So the impact that digital production can be when we use waste wood as our mainstream, right? So when we talk just very briefly about digital production processes, we are establishing new ways of design thinking connected to data management and parametric design tools, let's say in a virtual and computational environment that could connect, let's say, communicate and eventually generate robotic production processes, and the feedback loop between these two, so how design can impact production and the other way around. In the Circular Wood for the Neighborhood, we have had two explorations. The first one connects with our work package 2, which has to do more with the creative exploration of what are the possibilities. And later on, we bring this research into work package 3, which is the implementation in case studies. So following up with where Marta left you, where we are with this project, we are trying to explore the possibilities of this research upcycle wood factory, where we are understanding in further details the material supply, how can we digitalize a complex database of information and use this information eventually in our design and production processes to create some impactful applications, and perhaps even explore post-processing and assembly, packaging, etc. of these applications. So I'm going to go step by step to give you more insights on what we have been doing. We have been researching this material stream in all its different scales. So understanding in the micro scale, the material itself, perhaps even breaking down these door elements, window elements as a way to see what is in it, how is this material behaving, see what we get out from one housing renovation or one group of renovations, and what Nico was just previously talking, what is the bigger view of this material stream and how much this material is available. Later on, we are also exploring the digitalization of this material. We have been exploring through various research projects the idea of scanning and visualizing this material and translating either very basic geometry information, but also very complex, perhaps profile information, density, volume, image recognition to understand what type of wood are we dealing with, is it hard, is it soft, and creating this, let's say, 3D virtual database and also numeric database of the material that we are starting to have available. Also, as I was mentioned earlier, we are also exploring the complexity of this material. So it's not just, let's say, the bounding box of the material, but also we start to understand its different profiles, if it comes from a door frame, a window frame, is it a beam, etc., and what parts we can use, what parts we cannot use. And even further things like the type of wood, its density, its humidity, it has coating, no coating, metal inside, not metal inside, etc. So it is quite a complex material to work with. Since the beginning, we went to explore Hans' work on understanding the material and translating pre-processing systems to our robotic setup. So how could we turn this waste stream into a usable and upgraded class material that can be brought back into perhaps the housing or the building environment? Right? So also here you can even see the complexities of not only coating, but we explored in our research also metal detection, metal removal, planing, cleaning, pre-processing this material in order to make it available. So also when we connected to our digital production processes with this little case of turning an old door frame into a new window frame, we explored the possibility of perhaps by designing, we could already pre-process and post-process the material in one go to create this new application. So the idea of perhaps cleaning it first, creating a flat beam, and then making a new profile out of it is not necessary, because the robotic production processes and the computational design systems that we have embedded allows this to do in one go. So here we start to see already the advantages of the digital production processes. We also explored much more complex joinery systems. So we start to think, how can we even think further after this material has fulfilled its second life? Maybe it can be disassembled and reassembled eventually and reprocessed again. So we start thinking in the bigger vision of how it also is circular. So how it connects in a micro scale and also in its, let's say, life cycle. And also we have been exploring the same idea of post-processing. So how can also via robotic production we can create certain surface treatments, or maybe ensure we maintain a bit the spirit and the look of this material, but bring it to a more upcycled use. At the lab, at the Faculty of Technology, we have also been exploring this factory setup. So how can we process several pieces or several parts at the same time, have robotic collaboration, include the work with our students and our researchers together in order to come up with these different solutions. So this is something also very important in our research and our educational, let's say, programs connected to the Robot Lab. So our next, let's say, phase in the Circular Wood for the Neighborhood was to bring this research into actual case studies. So where we could explore in practice how this could be of an added value. So a bit to give you an idea, the goals of the work package 3 was to select actual projects from our partners, housing corporations, which can be used for the development. So we did a lot of on-field research, understand the material stream, the harvesting, where it comes from, where it goes, etc., etc. And for each case study, we are exploring the idea of finding a donor project, so where we harvest the material from, and a receiving project, which would eventually integrate the idea of these case studies. So the donor and receiver could be the same location, or it could be different locations also. So in this process, we are exploring design and prototype of experimental, let's say, applications that eventually can open us the conversation of its implementations. So our first case study is an indoor custom furniture element. It's in a more short-term, small-scale and personalized item. We call it once my door, now my coffee table. In this case, it's a direct connection between the tenant and the material that's being harvested. So almost its door or its window frame turn into some custom-made furniture that could be eventually used in their housing. So it gives a direct connection. And eventually we start to see it has a collection of items that could be customized and produced, right? So just this is an explanation of what I was telling you earlier. So we engage with our smaller community, and it's a very one-on-one relationship between the material, the donor, and the receiver project, right? So we have already aligned with our different partners, the harvesting projects and the receiving projects and the woods that we would be exploring. To go further in detail, together with the researchers at the Robot Lab, we have explored a design framework, also connected eventually to a robotic production process, where we explored a bottom-up approach. So instead of saying we're going to design a type of coffee table that looks like this and we apply the wood, we start from the wood itself to create a system based on rule sets of aggregation perhaps or connections that no matter what kind of wood we have, we could embed it in this computational design framework and start creating different different furniture. So it's not only one specific, but the outcomes could be as many as we wish. So a bit idea here was that in our idea of pre-processing this door frame, we already are cutting in an informed way the material so we don't create any waste, additional waste. And also by having these subcomponents, we are thinking and looking forward to an easier transportation, an easier assembly process, and further let's say design options. So just to give you an idea, an initial exploration was these different kind of objects that could come out from this design system based on its rule sets. And eventually we found it quite interesting. We started to prototype with a group of students how this could look like, what types of connections we could have. And from here we iterate. So it's very important, the iterative design process where we iterate the computational framework to start to understand a bit also which rules we need, how can we resemble perhaps elements that the tenant would engage better or not. And also we start to see even at the, let's say, the material level, how we could customize its look, its feeling, its finishing with the idea of this computational design. And we see it here, one beam that could be, let's say, treated the surface based on which kind of pattern we would like, but also you could see it in the full element and the overview of the full element also having this kind of look and finish. Also in this process, we explore how we can create joineries, right? Just as I mentioned earlier, that can allow easy and dry assembly and disassembly. Almost kind of this little Lego kit that the tenant could use and build his own furniture pieces that are custom designed, right? So here we kept on iterating and looking forward to creating a couple of new prototypes that could explore further this idea. So currently we have been working on these two ideas of having a fully pre-processed system and perhaps an unprocessed system that is more hybrid. The added value of the pre-processed perhaps is that we have planed and really clean all the beams, have this kind of new class material available. We digitalize it and design with, let's say, these perfect squared elements that will bring us a high level of accuracy and finishing, right? But perhaps a major time of production versus an unprocessed one that from, let's say, the starting process, we have it in our digital database with all its complexities of profile shapes and, let's say, even surface treatments. By processing the material, we can create these connections, customize the feel and look, and at the same time preserve its original feeling, right? So we kind of connect with this circular element. Of course, this one is in a much less time of production and design processing, so it's very interesting, let's say, the exploration between these two. So how would an unprocessed stream look like and a pre-processed stream look like? And what were the added values of the exploration when we did the fully pre-processed, where our levels of accuracy were, let's say, in the 95 to 100%, which is quite an achievement. But at the same time, the multi-production processes would allow to create the connections, and let's say this final piece has an outcome. We are currently working on the unprocessed version, so how can we work with a much more complex computational database and start understanding, let's say, which parts of this volume we can use, which parts are not usable in order to create these connections. So also the production computational system is a bit more complex, where in this video, I cannot scroll it through, but basically we tackle, thank you very much, we tackle the different parts in different processes that could be done simultaneously by the robots, by creating the connection, taking out the parts to create the interlock between objects, but at the same time also the surface treatments that are required. Just to give you an idea that we saw earlier. So this case study 1 finishes with this last prototype that we're exploring, where we are looking to different surface treatments, but at the same time maintaining a bit the initial value of this wood stream, right? So basically the exploration of case study 1 goes through this iterative design to production process of several prototypes that again can give us some insights on this idea of once my door, now my coffee table. Our next case study is an outdoor structure. It's a community element that has a much more midterm and medium scale, but it's more in the collective spirit. So this idea is once there are windows, now our playground, where we look at the bigger scale of these housing renovations. So when big projects of social housing perhaps are in a renovation process, all these windows and door frames are extracted. We could use a bigger database of material to create these kind of outdoor structures that could bring together the community. So at this scale, we're also looking at the tenant engagement, which Marta mentioned earlier, and also more complex computational design explorations. Of course, we also have a donation project and a receiver project, and we start to see also the type of wood that comes out. So for instance, one of these projects that we're working with is using outdoor cladding, so it already comes with certain properties that could be reused in an outdoor situation, right? So in order to achieve this project, we have been exploring in much more detail the complex database. So we are really taking into account, let's say, the material and its geometry, but also in its performance and integrity. And we are also connecting it to more complex structural design tools that could also connect the relation between the material and its performance. So for this project, we are quite inspired in the work of Aldo van Eyck when it comes to designing these playgrounds and a bit the idea behind creating this more playful elements for the children and adults in a space to create this community engagement, right? So the basic idea of this design to production system has to do with using the full stock of wood that we have available, where you could manage the data based on perhaps if it's hardwood, softwood, if you want structural integrity in it or not, perhaps cross-section profiles, density, weight, etc., and connected to a certain target design or target structure, Yes, where we fit the material to the design, and this design in this idea of a dynamic simulation can adjust to fitting the material. So there is an intrinsic relation between the material that is available and the design, how it adjusts to what we have available. So it's not a straightforward, we put the wood however it fits, but it's a relationship between the material and the design system. So we have been exploring with these computational design systems how to populate these different designs and optimize them based on the material that we have available, where we can control as a designer, perhaps if we want to have a more fitting option or a less fitting option. So we can have a range of how this will be as an outcome of design based on how strict we are with the use of material or not. Right, so this all has its own working environment, right? So in this one, we have been exploring this idea of bigger structures that could be more abstract for the kids and the adults. We have looking into open structures and closed structure systems. And very briefly, to take you through the closed structure, you could see here on the left side the wood database, so a kind of a visualization of the wood that is available and how it fits and adjusts this kind of igloo structure in order to be able to build it. eventually we take it to a much more further analysis where we take into consideration the structural integrity of it, because it wants to be an outdoor structure, perhaps even a climbable structure. So we can also incorporate perhaps ideas like the class of the wood, the structural ability, the material performance, in order to create these elements. So it will be according a fitting or a structural analysis according to the material that is available. The other exploration is these more open surfaces, kind of creating canopies, sheds, or perhaps elements that could connect with the nature that is in these community gardens. And it has a similar strategy of an informed fitting based on the material stock that we have available. So here you can see these different wood elements adjusting to optimize its connections and its fittings. So our next step with this research, of course, it's to actually connect the database of the material that we are harvesting from these donation projects, do some tests of connections and prototypes, and see what could be the vision of actually building up this element. And of course, also seeing how could we integrate the tenants in this either design or production process, or perhaps even an on-site assembly. So we are in talk with our partners to see how these elements also can be connected with the tenants, and also they can take ownership of the work or this object that they are co-creating together with us. We are also starting to look in which kind of connections we can have here, right? Some ideas are of a modular, perhaps steel element, or on the other hand, fully wooden panel connections that could help building and making this a structure that could be placed eventually on site outdoors. And of course, we are looking to the idea of the assembly. So how do we connect the robot production systems with human assembly, and perhaps some augmented reality ways of informing the assembly of these non-standard structures and non-standard material. So this looks at the idea of once their windows, now our playgrounds. And finally, just to wrap up, I think I'm running already out of time, but
few minutes.
we are almost there. This is our last case study. We are looking into an indoor building element, kind of an interior application that has a much more long-term and bigger scale overview. So in this one, we have this idea of once burned windows, now shared value, right? Where we are looking at all the scales of harvesting projects that these corporations are exploring. So it could be the very one household harvesting, or a full, let's say, building renovation, where we start talking about the idea of a shared material bank. So I think this is very interesting when we are with this big consortium of different partners and different stakeholders, and we start to discuss the idea of what if we shared the information of how much wood we harvesting per year, or we kind of start to document or create this database of the material that starts to be available. We connected to this idea of a digital production system and create circular building applications. So not one element or for a little group, but we're talking about perhaps a more standard wall division panel that could be done out of this non-standard stream of waste. But at the same time, we could have a system that could be perhaps brought back to the bigger housing renovation. So this looks a bit at all the wood that we have available currently, and we have been working with, I don't know why we have slides disappearing, but I can explain it with this image, where graduates from the built environment of the Faculty of Technology that are working with us have been exploring the idea of designing and producing an interior division element made out of the circular wood. So in their research process, they came up with a design matrix where they established different conditions that would be, or parameters that could be interesting, such as design opportunities, customization, production time, use of material, let's say easy assembly or not such easy assembly, and they could create these ideas. So the matrix eventually visualizes a bit like this material exploration that I did, where they saw different types of perhaps material arrangement and connections that could eventually come up with an idea of an interior division element. So they proposed a multi-scale design to production system where they explored digital design and robotic production of circular wood to create an interior division element. So they tackled it in 3 different scales. In an architecture scale, they focused their research in, let's say, a family housing, 3 people, let's say a couple and kids, family around 70 to 80 square meters, and they start to understand how the interior layout could be rearranged depending on the spatial needs of the user. And they eventually came up with this interior design element, which could either divide existing spaces, for instance, very popular now, the home office that we all look for, but also it could already be embedded in the planning before the whole layout of the building is done, right? So it could be a division between rooms, it could be a storage, it could be some kind of architectural integration. So eventually, to get to this is a bit the vision of what if it would happen in the bigger scale, perhaps eventually in the lobby of a hotel or in some commercial areas. So they had a vision of the big scale. Eventually, they also went to the element scale, where they start to look at the wood that starts to come available and how they could create this kind of system of profiles that can turn and can open, close, and fulfill this matrix design that they had.
Can we wrap up?
We are, yes.
Because we're running out of time.
For sure. So I will quickly walk you through the material scale, which is where they actually went into producing a prototype of this element. As you can see here, they saw the different connections, and eventually they built a prototype that explores different kinds of finishings, such as keeping the wood as it comes or fully cleaning it, processing it, and oiling it as a final product, right? So you could see here the assembly process and how they achieve their final prototype. So actually, we could here finalize looking at the big waste stream, how we could use this material shared bank and create these kind of applications. So I would say this is the work that we have been doing now. We will soon be exhibiting this work, I think end of July.
Yes.
So keep tuned for results.
Sure. Thank you for this presentation, Marco. It's a long presentation. There's a question from one of the participants asking, could you also work with a range of different materials? For instance, also with wood coming from tree or other type of materials. Could you work together with them in this way of designing?
Yes, definitely. I think that the fact that we are thinking of this idea of digitalizing the material, right, and connecting it with a design framework, the possibilities are endless, right? And I think that eventually we would like to explore the more hybrid work, right? I think that the case study 2 already hints a bit the need of perhaps other type of materials to create the connections in order to ensure stability or a climbable structure. So I would say definitely yes, and it also looks at the bigger idea of waste streams.
Yes. There's also a question about the economies of the process of customizing the scanning of incoming materials and designing with them. But I think we will also ask Marta to join us for this question about the economies or the more business kind of circular wood. One final question would be, how are the housing corporations? How are they responding or to the different cases?
Yeah, I think that is a very, very interesting question. We have regular meetings with all the partners, and I would say that once we arrive to to this last part, the case studies, is where we started to get more this positive feedback, right? Where you start to see actually that it is possible to process waste streams. It is possible to create impactful designs. And I think that they have been always engaged in the project and supported us and gave us a lot of insights when it comes to the material perhaps or the processes. But I think that we are kind of now in a point where we are aligned, right? And we see the possibilities and the future of using circular wood.
Thank you very much.
Thank you.
I would like to ask Marta to join us as well for a final wrap-up of this webinar. You had some time to think about recommendations. And as I know you, this will be a very extensive, let's say, wrap-up of what you see as key, or maybe the first recommendations which come to mind. So please, maybe you can share your thoughts, and then Marco and I think we will also give some more insights.
Okay, I have done my homework. I think I can summarize the recommendation in 10 points.
Oh.
And I will try to be as sharp as possible. And I will start by saying that one of the things that we see clearly, especially in conversations with people like Metabolic, for instance, is that the circular ambitions of the governments and the housing demands that we are facing make it very, very clear that there are not enough virgin materials to respond to these housing needs. And therefore, that the increase on secondary materials is clear, or the demand for secondary materials will be clear. So, and then also we see that municipalities could have a role when requiring and making, for instance, harvesting wood a requirement for the coming years. So considering this, point number one of implementation strategies would be to create awareness for all housing corporations of the scale of the problem and the scale of the wood that they have available, how much value they have already. So that's number one. Number two is that we need to organize the collaboration between these housing corporations, because it seems not possible that one housing corporation alone can eventually invest and eventually explore this territory by themselves. It would be much better when it is collectively supported.
Before you continue, I would like to give you the opportunity for a third recommendation, and we will keep the rest, the other 7 we will keep for the exhibition. Okay,
then I will do 4.
Okay.
Then I think that having a pilot project where actually we have spoken with several housing corporations, and they say that the changes that we see implemented need to be brought up little by little. And so where we can show what is possible, and then that begins, creates protocols for the future. So a pilot project where several housing corporations could be working together in an area where there are many buildings of the same kind of typology that will therefore be renovated more or less at the same time, could facilitate that they can maybe experiment with what would it mean to align their planning for renovation, share resources for these renovations, and eventually collectively engage on the possibility to harvest circular wood and process it. And that leads me to the number 4 recommendation, is that if we did this involving their tenants, that could have a saying in what kind of real demands they have, or what is the actual value of this material for them, then I think that we could tie this very well with the primary business of the housing corporations, that is at the end social impact, and we could connect that to creating awareness for sustainability and improving the quality of these type of neighborhoods that are, generally speaking, in the outskirts of cities and in areas that are a little bit less, if you want, desirable, and that present a lot more challenges.
Okay, thank you for this for these 4 recommendations. Is there one you would like to add to this, Marco, from your experience from the 3 case studies?
Yeah, I would say let's don't fear technology. I think that the one thing we're talking about society, circularity, but also a lot of the work that we've been doing has to do with connecting with robots, with computational design systems, and I think that the work that we have done also with researchers and the students is to discuss and reflect also on our roles as designers, as engineers, as architects, has housing corporations, as builders. I think that we are in a time that we need to start integrating more multidisciplinary work, and I think that is something very beautiful that we have achieved with this project.
Okay, thank you. Nico, you are still online watching us. Would you have one recommendation from your work in this project so far?
Yes, I think a lot of great things have already been said, of course. The main addition, I think, is I would have 2. Insight into impact is something that's very often forgotten in decision making. And the second thing would be accessible data and data exchange, so that processes like these can happen without too much hassle, and you can really make sure that you get to the most impactful and interesting and also beautiful prevention possible.
Thank you for this for this summary, and I must say this also is partly my own summary, what I've learned from the project. When we started, I thought, well, we can document quite easily how much wood these housing corporations have in all their buildings, but this was not possible because their whole system is very fragmented, because they originate from very many smaller housing corporations, have been joined together in the last years, so they don't actually know how much materials they have right now. So starting with first having a survey of all materials will not be very effective, I think. It will also give them a lot of work without seeing the actual results. But I think the cases which we made in the end, which were very practical and it can be seen, and this really gave them a spark. Well, this is something we can show to our tenants, we can motivate them to become more circular, and their management as well. So I think having more concrete projects as a follow-up, as you said, maybe scaling it up to a larger quarter, I think would be a very nice first step for me.
And with the exhibition?
Well, we will
serve for that.
We will, yes, as already announced, we will be putting together an exhibition with the case studies, with the work from Metabolic, etc., which will be run in June to complete this project before the summer. So I would ask everybody to keep posted, and we will announce where the exhibition will be. It will be somewhere in Amsterdam, of course, at the housing corporations, maybe at the municipality of Amsterdam. So keep on watching us, and we will share. We will organize some events at the exhibition, and there share some more insights with you. With that, thank you very much for joining us, and looking forward to seeing you in live, maybe in some other occasion. Bye bye.
Thank you.